Hello everyone, I'm Shravani Saugule and today I'll be presenting my topic Ontologies, Design and Use in Artificial Intelligence. Ontologies are important concept in AI because they help machine understand the meaning behind the data and not just the data. Moving on to the introduction of ontologies, in AI, one of the biggest challenge is handling unstructured and diverse data. Ontologies solve this problem by giving structure and meaning to that data, allowing systems to reason, make connections, and understand the context. That's why advanced systems like Google Knowledge Graph or IBM Watson use ontologies for intelligent reasoning. Now let's see the meaning of ontology. In simple words, ontology is a formal description of concept and relationship in a domain. It defines how different entities are connected. Here there's an example. Now here, in a medical ontology, patient has a symptom, fever, and it is diagnosed by a doctor. So AI will understand how these concepts relate and not just their names. Now let's move on with the principles of ontology. The main principle behind the ontologies is to provide a formal structure for knowledge. That means defining clear concepts, relationships, and rules that AI can reason correctly. Ontologies are built using logic based language like OWL, and they follow a hierarchical or subclass model. Now, let's continue with the importance of ontologies. Ontologies make sure that AI share a common vocabulary and understanding. It helps in data consistency and reuse of knowledge. Finally, the characteristics of ontologies include they have a formal structure for accurate reasoning, a hierarchical taxonomy for organizing data, relationships that link concepts and properties, and a shared vocabulary that reduces confusion between systems. So overall, these principles and characteristics make ontology the backbone for meaningful and logical AI reasoning. Connection between ontologies and knowledge representation. This part is very important because the topic connects directly with the knowledge representation. Ontologies provide the structured vocabulary that knowledge representation uses. So when AI performs reasoning or inference, it actually depends on the ontology to understand how concepts relate. In short, knowledge representation tells AI what to store, and ontology tells us how everything connects. Now moving on to the next slide, types of ontologies. Now there are mainly four types of ontologies: domain ontology, task ontology, application ontology, and upper ontology. Domain ontology for a specific field like medicine. Task ontology for particular tasks like e-commerce. Application ontology combines both tasks and domain, and upper ontology, which defines the general concepts across domains. This classification helps AI work at different levels of abstraction. Moving on to the applications of ontologies in AI. Ontologies are widely used in data integration, product recommendations, environment understanding, health diagnosis. They're also used by AI systems like search engines, chatbots, and disaster management systems. Let's get the topic very clear with the case study, disaster management ontology. Now here a practical it is a practical case study. During disasters, data comes from weather reports, satellite images, and emergency bases. So a disaster ontology connects all these sources together through a central ontology information, and this helps AI systems coordinate and rescue the operations faster. A perfect real life example of how ontology supports decision making. Let's move the features of ontologies. The main features include semantic richness, hierarchical structure, machine interpretability, supports reasoning. That means AI doesn't just read words, it actually understands their meaning and relationships. Future of ontology. In future, ontology will merge with the large language models like ChatGPT and autonomous systems. They'll help under updating in real life and make AI decisions more explainable and transparent. Ontologies will also support self-driving cars and robotic systems to reason safely. Benefits of ontologies. Ontology brings many benefits like semantic learning. AI can interpret meaning. Data integration combines multiple sources. Third is logical reasoning. AI helps it helps AI to derive new facts. Reusability. The same ontology can be work across domains. Better recommendations, like in search engine or in e-commerce, these advantages make ontologies a backbone of intelligent systems. Comparison, benefits versus challenges. So when we'll compare the benefits and challenges, ontologies clearly offer huge value in understanding and reasoning. But we must balance that with complexity and cost. It's all about designing them efficiently and keeping them updated. The benefits include like semantic understanding, logic reasoning, data integration, better recommendations, while the challenges include complex development, high maintenance, scalability issues, and integration conflicts. These are some of the ethical issues in ontologies. We'll need to consider this also. Ontologies can include sensitive data, so privacy and transparency are critical. There's also a risk of bias or misuse of knowledge, as sometimes it's hard to assign accountability with when AI makes mistakes. That's why ontologies must always remain open, explainable, and responsibly designed. Now let's conclude this. In conclusion, ontologies give AI a structured semantic foundation. They make reasoning, knowledge sharing, and interoperability possible. Despite the challenges, their future is bright, especially when linked with large language models and explainable AI. So, and also these are the some references which I gave, which I took information from. And also, thank you very much for watching this session. Thank you so much.